To add and subtract any type of fraction, you need a common denominator. So even though these are more complex than your standard fractions, you still have to look for a common denominator. What you're going to do is make sure that everything is in factored form and that you use at least one of each type. And if you can reduce ahead of time, you want to. These are not, you cannot reduce these. So you can't reduce anything here. You can't reduce anything here. Remember, these are grouped, so you can't reduce part of a group. They have to be identical. So my common denominator here is actually going to be the whole grouping, the n minus 2 and the n plus 5. I'm then going to take each numerator. So I'm going to take the n plus 2, and I'm going to look and say, well, the n plus 2 has that n minus 2. All I need is the n plus 5. So I'm going to multiply by the n plus 5. Then you're going to put whatever sign is in between it, which in this case is a plus. And then I'm going to look at the next numerator. The next numerator is 4n. When I look, it has the n plus 5, but it needs the n minus 2. So I'm going to multiply that by the n minus 2. And now I'm really just simplifying. So I'm going to FOIL or distribute, and then I'm going to combine my like terms, see if anything can be simplified. So I'm going to FOIL this one. I have n squared plus 5n plus 2n plus 10. Plus we have 4n squared minus 8n. My denominator remains the same. Once I find the common denominator, that is my denominator. My numerator, I'm going to combine like terms. I have n squared and 4n squared. That is 5n squared. I have 5 plus 2 plus negative 8. That's negative 1n. And then I have a plus 10. On the bottom, I have the n minus 2 and the n plus 5. All right. If I could factor that top piece, I would do that just to see if anything cancels, but nothing actually reduces here. So this is my answer. This is where I'm going to leave this one. Your first step, so if you were like thinking about how do I go through this process, the first thing you want to do is find your common denominator, right? You do that by factoring anything and use all the factors. So that's basically what I did here. I said, well, this only has one factor, that's going to be used. This only has one factor, that's going to be used. So I found my common denominator. This is my common denominator. Then I'm going to go back to my numerators. My first numerator was the n plus 2. So I looked to see what did he originally have. He only had the n minus 2, which means he was missing the n plus 5 from my denominator. He didn't have that originally. So I need to multiply him by what he's missing from the common denominator that I have found. Then I'm going to go to my second numerator, the 4n. He has n plus 5. So he already has this n plus 5. He was missing the n minus 2. That's why I multiplied by the n minus 2. So my first step is to find my common denominator again. But in this case, I am going to have to factor first just to see if there's anything in common. So when I do this, I'm going to look for factors of 6 that add up to 1. All right. To get my common denominator, I have to use these two. So I'm going to use the p plus 3 and the p minus 2. I also have to use that 5. So that whole thing is my common denominator. I have to use every single piece of that. So I'm going to go ahead and write down my common denominator. And then I'm going to go back to my numerators. My first numerator is p plus 2. The p plus 2 has the p plus 3, the p minus 2. It does not have that 5. So I'm going to multiply this by that 5. That's what it is missing. I'm going to look at my next numerator. So again, make sure you check these because these could be addition or subtraction. In this case, it's addition. I'm going to look at the next numerator, which is 2. It only has the 5. It's missing this entire group. Now, you can write it down as the groups, but you already know what happens when you FOIL it because you've already factored it, right? So you're going to have to FOIL it before you distribute that 2 anyway. So I would actually just go ahead and write down what it looks like FOILed. But you can write down the p plus 3, the p minus 2. It doesn't matter. But you already know what the FOILing is. So you might as well go ahead and write that down because that's how you're going to distribute it. And now I'm just simplifying. I'm going to distribute this 5. I have 5p plus 10. I'm going to distribute this 2. I have 2p squared plus 2p minus 12. And then my denominator should stay exactly the same. All right, I want to point out one of the most common mistakes I would see for this one is I would have someone cancel these. I cannot cancel those 5s. This 5 is part of this whole group. I can't cancel it, all right? If I could take a 5 out of that whole group, then I could cancel my 5, but I cannot. So I'm going to simplify my numerator and then see if I can reduce anything. I have a 2p squared. I have a 5p and a 2p. And then I have a 10 and a negative 12. Again, if I could factor that numerator and simplify it, I would, but nothing here simplifies. So I have my final answer right there. So when I look at this, neither one of those are factorable. So my least common denominator is just going to be that n minus 2 and 5n plus 6. I'm going to do the same exact process with subtraction. I'm going to take that 6n and I'm going to say, well, the 6n already has the n minus 2. It just needs the 5n plus 6. And then you're going to make sure you put subtraction here. You have the 4n, which already has the 5n plus 6, but it needs the n minus 2. And then I'm going to distribute and simplify. So we're going to distribute the 6n, the 5n, the 6n, and the 6. And then here, distribute the negative through. So negative 4n times n is going to give me negative 4n squared. The negative 4n and the negative 2 give me a positive 8n. So when you have subtraction, that second group has to have that negative distributed all the way through. My denominator is going to stay exactly the same. And then I'm just going to simplify from that point forward. So I have 30 and negative 4 will give me a 26n squared. The 36 and the 8 will give me a 44n. You can actually factor that. It doesn't actually help you. So you could take a 2 out and an n. So if I wanted to leave this completely in factored form, I would take my common factor out up top. I would have 13n plus 22, and then I would have this down here. But again, I can't simplify anything, so I will actually take either one of those answers as the final answer. So your first step here, even though this looks completely different than addition, is actually the same as addition. Your first step is to find your common denominator. The difference is you're going to look at every single one of these. So I have a 3, an m, and an m plus 1. Here, I only have to use, just like any common denominator, I only have to use each term once. So I have to use the 3. This is m to the first power, and this is m to the first power. So I only have to use it once. If one of them had been squared or cubed, then I would have had to use the highest. But m and m are the same factor, so I only have to use it once. And then I have to use the m plus 1. So my least common denominator here is the 3m plus 1. All right. I am going to take that common denominator. So once I find my common denominator, I am going to multiply every term by my common denominator. So multiply every term by that. So if I have multiple terms on top, multiple terms on bottom, every single one of them is going to be multiplied. This is going to get rid of my denominators. I'm going to multiply this by 3m, m plus 1. I'm going to multiply this by 3m, m plus 1, and I'm going to multiply this by 3m m plus 1. All right, your goal here is to get rid of every denominator. So I'm going to cancel everything that can, which should be every denominator. So this 3m cancels with that 3m, and I'm left with just the m plus 1, m plus 1. That is my numerator so far. In the denominator, I can cancel an m here, and I'm left with 3 times the m plus 1 times the 9. Here, I cancel the entire m plus 1. Don't forget your plus in the middle there. And I'm left with 9 times 3m. All right. And then I am going to just distribute, FOIL, etc., and solve. I cannot, again, I want to point out common mistakes here. Most common mistake would be to cancel one of these m plus 1s. Your tendency is to do that. You cannot cancel one of those because this is part of this entire group, okay? So you cannot cancel one of these because there's a plus sign in something else that doesn't have it in it. And so you cannot cancel there, all right? So I am going to just simplify it. I'm going to FOIL that top. I have m squared. You're going to get 1m, so you're going to get 2m, and then plus 1. That's my top. Here I have 9 times 3, which is 27. So I'm going to distribute 27 times m and 27 times 1. And here I have 9 times 3 times m, which is another 27m. I'm going to combine like terms now that I have FOILed. The top is as simple as you can get it. So the top is finished. The bottom, I can combine my like terms of 27m and 27m. You could factor the bottom. You would just get 2m plus 1. So if you want to factor and just make sure nothing cancels, you can do that, but nothing cancels. So this is your final answer here. First step in solving an equation is to find your common denominator, okay? You are going to treat this almost identical to your complex fractions. You're going to find the common denominator, multiply everything by it, and then you won't have any denominators. And now you'll be back at just a basic solving an algebra equation. And so for this, I am going to, again, look at all of my factors to find that least common denominator. I have a 2. I'm going to have to use the 2. I have an r squared, r squared. R squared, and r squared are really all the same factor. I just have to use the highest one to make sure I included everything. And so I'm going to use the r to the second power because I have an r to the first power and r's to the second power. So I just have to use the r to the second power, and that will be my least common denominator here. Once I've done that, I'm going to do exactly what I did on the prior page. I'm going to multiply everything by the 2r squared. So I'm going to multiply every single one of these by the 2r squared. And I'm going to cancel the denominators. So in this first group, I have the 2 can cancel and one of my r's can cancel. So I'm left with just 1 times r. Put my equal sign down, don't forget that. In this next group, the r squareds can cancel, and I'm left with that 2 and the r plus 3. Then put your plus sign, and I have the r squareds that can cancel, and I'm left with just 2 times 2. And so now you can see that you have a rather easy algebra equation here. I'm going to distribute, combine like terms, variables to one side, numbers to the other, solve. Okay? So from this point, I'm just going to distribute. R equals 2r plus 6, and then I have that plus 4. Combine my like terms, I have r equals 2r plus 10 move your 2r over. Negative 1r equals 10. We're not done. You have to get the r by itself, so you do have to divide by that negative 1. R equals negative 10. I do need to check for extraneous solutions. It is in your instructions. There's actually only one number that would cause me a problem in this particular equation. If I look at my original denominators, remember when you have a denominator, what can you not have in the denominator? 0, right? So as long as what I plug in does not make it 0, I'm okay. If I plug in a negative 10, that would be negative 20. This would be 100. This would be 100. Negative 10 works. All right? Had I gotten negative 10 and 0, then 0 wouldn't have worked, because when I plug in a 0 here, it would not work. Now, that doesn't mean 0 always doesn't work, because that could be a plus or minus. But in this case, I have to check and make sure that what I have gotten does work and does not cause a problem in my denominator. So for this one, when I'm finding my common denominator, I do want to make sure everything is factored. All right. And so part of the process of finding that common denominator may mean that you need to factor some of your binomials or trinomials. This is a special case. This is x plus 5, x minus 5. This is the same special case, x plus 5, x minus 5. All right. So I need to use the x plus 5. It's only to the first power every time, so x plus 5 will be part of my denominator. I need to use the x minus 5. It is also only to the first power in any one of my denominators, so x minus 5. So that means this is my common denominator, x plus 5, x minus 5. And then I am going to take each piece of my problem and if it will let me, and I'm going to multiply it. So I'm going to multiply each piece by just the common denominator, and my goal is to then get rid of all of my denominators. So if I look at this, I'm going to take the x over the x squared minus 5 and multiply it by the common denominator, which is the whole denominator, by the way. And same thing here. All right, this in factored form is the entire thing. So the whole thing cancels, and I'm left with just the x. Here, just the x minus 5 cancels, and I'm left with the x minus 2 and the x plus 5. Don't forget this is subtraction, so write your minus sign. Here, x squared minus 25 is the whole thing. So x plus 5, x minus 5, and I'm left with just the 5. And then once again, I am solving. So I am solving by just distributing and getting my x's where they need to be to solve. In this case, we're going to have to do something a little different, but that's okay. So I have x. I'm going to FOIL this, x squared plus 5x minus 2x minus 10, and then this minus 5. Combine my like terms. I have x equals x squared plus 3x minus 15. And then I actually, when I have a square, remember when you have just x to the first power, move your x's to one side, your numbers to the other, divide. When you have something squared, you're going to have to actually move everything to one side and set it equal to 0. So I'm going to move this x over, and I am going to be left with x squared plus 2x from this right here minus 15 equals 0. So how do I solve a quadratic? What do I need to do here to solve and see what x should be? Factors of 15 that subtract a 2, right? What are those? Yeah, so it's plus 5 and negative 3, right? And then I'm going to set each one of these equal to 0 to see what my x will be. So x plus 5 equals 0, x minus 3 equals 0. X will equal either -5 or +3. And then I'm going to go back to my original equation, right? And I'm going to say, will this cause a problem? -5. Will that cause a problem here? -5 plus 5 gives me 0. That's a problem, right? If it causes a problem in any one of my groups, I have a problem. So -5 is an extraneous solution. I am going to say that is not going to be one of my answers. My only answer here is going to be +3. So this is my only answer because -5 was extraneous.